Hello, repair time again. I just love fixing stuff, and especially lab equipment, and I highly recommend this to anyone who wants to get affordable test gear, or to anyone who wants to learn electronics and doesn't have particular project in mind, or just for fun. So this is a power supply which can do up to 18 volts and up to 5 amps, and it is branded Array, and the model is 3644A. And I've seen on eBay a lot of other equipment with very similar look and different brand names. I believe I've seen Tech Power, and I think I've seen Aten. And have a look, here I have electronic load, which is branded ppm. It was described as blowing the fuse. So let's turn it around. Have a look, there are two stickers and they're still intact, which is good. It means probably no one was inside yet. So let's crack it open and start looking. I opened the thing up and I didn't see anything obviously wrong. So I started checking the fuse, and the fuse is indeed blown, but this looks to be a 3 amp fuse. And have a look at this. Here is this label on the back saying that for 120 volts, which we have here, the fuse should be 6.3 amps. And the voltage is set to 115, which is correct, but the fuse was incorrect, as if it was set for 220 volts. Well, could it be the only problem? I don't know. I doubt it. However, I have a few 6.3 fuses sitting around, so I think I should sacrifice one to find out. So I put a new fuse, 6.3 amps in, and I forgot to turn on the camera before I tried to power this thing on. What happened is that it blew the fuse right away. However, I noticed in this area, somewhere behind the transformer, there was a big spark. So I think something is wrong with the transformer. So let me unscrew it and have a look. So it was easy to unscrew the thing and disconnect the secondaries. However, the primary is still connected there. It needs a little more work to disassemble that part. However, have a look at this. This is the source of the spark. Let me zoom in. So, as you can see, the insulation is burned through. Is this good or bad? Well, on the one hand, this certainly looks repairable, and probably nothing else is wrong except the transformer. On the other hand, rebuilding this transformer can happen to be a lot of work, and it depends largely on where the damage is. If it's just on the surface affecting the secondary, that it can be quite easy. Well, if it's very deep, affecting all the windings, primary and secondary, then I need to remove everything and then put a new wire in place, which can be a lot of work. And rebuilding these toroidal transformers has a positive side and a negative side. On the positive side, there is no need to disassemble the core, It's a real pain to disassemble that split laminated core, which consists of million small pieces, and you need to be careful removing them somehow and careful putting them back, and transformer can be noisy after that. It's sort of hard to compress it again as it was without special equipment. On the other hand, on the negative side, is that everything needs to be done through this hole. All the windings are removed and put in place through this hole, which is not very convenient. So I'm going to give it a try. At least I'm going to disassemble it to see how deep the damage is. Here we are. After a bit of work and some swearing, I removed this transformer. I marked the wires and the corresponding terminals they were soldered to. And let's have a look. Everything is in Chinese here. GB 150A. And apparently this has 110 volt secondary, two 15 volt secondaries, and the main one with several taps, 0 to 13.2 volts, then 23.1 and 29.3 volts. Okay, the next step would be to start tearing it apart. So here I removed this external layer of insulation. It was very easy, it was not glued or anything, just the end was attached with a tape. And it's certainly usable if I happen to put this thing back. And let's have a look at the burn. It seems to me that the burn is deeper than this external secondary. And in fact, I'm almost sure, because of the big spark, it is primary. The high voltage is involved. So, and the primary is usually the most inner winding, the first one. So most probably I need to remove everything, and that means carefully count all the turns and save all the wire and see if it's usable again or needs to be replaced. Alright, so with the help of this shuttle I managed to remove the first section from white to green wire, and I counted 31 turn. I managed to remove this last thickest secondary, which has 3 sections, so I used these 3 shuttles and counted all the turns, and because this label has the voltages, and I counted 31, 50 and 66 turns, which gives me exactly 5 volts per turn. And let's have a look. Now we see this burned spot better. And by the way, that thick wire I removed seems to be fine. It's not really damaged, so I can put it back perhaps. Not sure about the next section, the next secondary. So I removed one more layer of insulation, and here's what I see. These are the secondaries, the 10 volt and 15 volt secondaries, and I'm a little surprised they're not spread out all over the toroid. However, they are not affected by this burn, not damaged at all. So only the primary is damaged. Here we are. I removed the secondaries and the layer of insulation, and what I see is the primary is arranged in two sections. First section, which is thicker, and this is used alone when the mains is 110 volts, and the additional section, which is thinner, and it gets added to that when the mains is 220. And so this is wound first, and then next layer is this thinner section, and what I see here is that both are damaged, unfortunately. Well, here is the annoying part, because we are talking about 5 turns per volt, which means 550 turns each section, or 1100 turns the whole thing. I wish I had a machine to wind toroidal transformers, but I don't, so I'll try to tackle it manually. So here I'm removing this primary, and I'm halfway through, and I'm using this plastic whites by Dremel, and I made one more shuttle here, and I wanted to show how they've done this. They wound this primary with layers of turns on top of each other, and I think this is a bad idea, because the transformer is squeezed from both sides by these guys, and chances that touching turns will develop some kind of a damage in the enamel of the wire are high. So, and that's what I believe happened here. So the catastrophic failure we've seen, it was a short developed between the layers in the primary. So I believe the right way to do it is to remove everything, start from scratch, and have these adjacent turns close to each other, and when the whole layer is finished, have a thin layer of insulation, and then start another layer of winding. And that's what I'm going to try. And even if I'm reusing the wire, chances that two adjacent turns will touch at some spot, and precisely at that spot both turns have damaged enamel. There's chances of that are tiny. So I'll proceed with this thing and keep reporting the progress. Humpty Dumpty sat on a wall. Humpty Dumpty had a great fall. Let's try to put it back together again. So the primary is almost done, and I used electrical tape between the layers. I also put a little bit of glue to avoid humming. So here I wound the dual 15 volt secondary, and both sections were done at the same time with two wires going in parallel, and that's how it was done before. And I thought it's a good time to do a smoke test before going any further. So I connected the whole primary as if for 220 volts, because I want to test the whole thing, and of course it will give me half of the voltage on the secondary. So I connected one section of the secondary to the multimeter, and if this thing doesn't blow up, I expect to see about 7.5 volts. So let's give it a try. Alright, it didn't blow up, and I have the fuse here just in case. And as we can see, it shows 845 volts. Well, a little higher than the specs, but that's normal. No load at all. And I'm happy. So I will proceed with the rest of the windings. I'll probably check the other section. Let's see, just in case. Yeah, same thing, 845. Alright, so far so good. So here I connected just the 110 volt thick section of the primary, and sure enough I'm getting about double the voltage on the secondary. And by the way, this transformer runs quietly. I don't hear any humming at all, which is great. I'm happy about it. So here it is, back together again. And I've done another smoke test off camera just before putting transformer in to see if I finished all the windings and attached all the connectors correctly. And I forgot to show you the thermal fuse, which is embedded into the transformer, and it is sitting on the common wire of the primary. It's supposed to melt at 157, I think, degrees C. So, transformer ended up slightly larger than before. I believe because of these extra layers of insulation which I put in. At some point I even started worrying that it's gonna fit, but it did. So it's the moment of truth. Let's turn it on. There you go, it works. Let's check it out. $19 volts maximum. Turn the output on. Some relay was clicking. Alright, it's time for a load test. Alright, let's check it out. So first, let's see if the output is correct without the load. So now the load is off and it's reading 3 volts, which is correct. So let's change that. 8 volts, 11, 16, 19. Okay, so that without the load it's reading correctly. So let's try 1 amp load here. So we enable the electronic load and no worries. So it's reading 1 amp here and 1 amp here. So let's load it more. 2 amps, 3 amps, 4 amps, 5 amps. Something is slightly wrong. So the electronic load reads that the current is indeed 5 amps, but display here reads 487 for some reason. So it's doing the right thing. The power supply is supplying 5 amps, but the reading on the display is not correct. Alright. Well, let's try to drop the voltage to promised maximum of 18 volts. Well, still slightly off, but not much. Well, I think it's basically working. And let me warn you, don't try this at home. This was just beyond economical repair. I spent a whole weekend rebuilding this thing. Thanks for watching, bye!